Okay, let's get started. It is 12:40, right? That's when we get started here. And questions. I know that there's a question. There was a question on the yogurt problem, something like that. But anything else? So I was thinking that today I would come by at some point and do a homework check for a quiz grade. What do y'all think of that? Yeah? All right. Good. Yes?
I have a question. Like, on doing the homework, is there a way, like, we can, like, see if our answers are correctly on the line? How that works?
Okay, yes. How about we do this? But I've told you the answer key that I was provided for this, I already found some mistakes on. But I'm happy to provide it. But here's the deal. Let me first see that you're doing the work, okay? Let's get through maybe this week and part of next week. After that, I'll start providing them ahead of time. I just don't want people to get them and just copy down answers. And so once I know you're working, I'll be happy to provide them so you can check your work. All right? So, any questions? Yes? Number 6. Tell me what page it's on. And page 8, number 6. Sheila? Yes. Making cookies? Okay. So let's see if we have the same numbers on yours and mine, all right? Sheila was making cookies for the school parent-student dinner. In the blender, blender? Do you use a blender to make cookies? Okay. In the blender, Sheila knew that she had put 13 2/3 ounces of ingredients she had mixed together. So I'm just going to write that number down. 13 2/3. After she was finished, she poured the mix into 2 1/4 ounce cupcake tins. 2 1/4 ounce cupcake tins. How many of these cupcakes would one batch of this mix make? So what's your thought here? What are we going to be doing? Divide? So which way?
13 2/3 divided by 2 1/4.
That seems reasonable. Anybody disagree? Anybody agree? Gonna get some agreement here? Okay, that looks right. Now, anytime you're faced with a word problem, I always recommend that if all these numbers are messing you up, just change them to numbers that make more sense and then come up with some logical way of doing it. So for example, if she had, 40 ounces of mix and each cup was 2 ounces, then she could make how many? 20, right? Because you'd say, all right, divide 40 by 2 and you get 20 cupcakes. Does that make more sense that way? And then you go back and say, okay, well, all I have to do is take that and divide it by that. That might help in some problems, especially with that yogurt problem, which I'll talk about in a second. All right, so we're going to do this division. First, we have to convert this over. So 13 times 3 plus 2, 41 over 3. Divide that by 9/4. Good. And because this is division, we have to flip and multiply, right? Flip the second one. So 41/3 times 4/9. And do we get any cancellation here? I don't see anything that's going to go away in reducing. So what is that? 164 over 27. Okay, so does this answer the question? The question is, how many of these cupcakes would one batch of this mix make? Well, you're not going to say that many cupcakes because we're not going to make a fraction of a cupcake. Apparently, we're not going to. So what we need to do is figure out what whole number this is closest to. So just divide. You could use your calculator if you want, or you could change this back into a mixed number. All right, so let's go back without the calculator and let's just convert it to a mixed number. So to go backwards, you have to do that old school division. Remember this thing? So how many times does it go in here? 6. So 6, what's 6 times 27? So 120, 162. And you have, what, 2 left over here? Remember this? 2. And what did we do with that 2? Yeah, so there was a time where you did this. Remember that? That was like way back when. You put remainder 2, right? Okay, so we stopped doing that, and then we just wrote 2 and 2 27ths, right? Whatever we're dividing. So how many cupcakes can she make? 6 full cupcakes. And then how much mix would be left over? 2 27ths. Make sense? Good? All right. Now, the other question was about yogurt. Number 5. So how many 3/4 cup servings are in 2/3 cups of yogurt? And what's hopefully glaring at you in that question is that, you know, if I were to take a measuring cup, here's 2 of them, then, let's see, this would be about half, right? Maybe 3/4 would be here, let's just say. Say that's 3/4 of a cup. And 2/3 of a cup, this is 1/3, this is probably close to like 2/3, is like that. Y'all agree? So they're saying how many 3/4 cup servings are in 2/3 cups of yogurt? And so that doesn't make a lot of sense in the real world, does it? Because you're asking how many servings that are bigger than how much you have. But you can still determine this if you, again, look at it a different way. Let's say you had, what was this? Cups, they were measuring in cups. Let's say you had 2-cup serving, okay? That's what 1 serving is. And let's say you had over here 30 cups. So how many 2-cup servings are in 30 cups? 15. How did you do that? You took 30, you divided it by 2, right? So what you're going to do here is, however much is here, you're going to divide it by the serving amount. So I need to take over here the 2/3 is how much I have, right? A serving is 3/4 of a cup, so I'm going to take 2/3 and divide it by 3/4. Does that make sense? 2/3 divided by 3/4 is the same as 2/3 times 4/3, yes? Which is, nothing reduces, so 8/9. In other words, if you have 2/3 cups of yogurt, that's actually 8/9 of a serving. If a serving is 3/4 of a cup. It's just, yeah, they're just trying to confuse you. We good? All right, let's move on. We're a little behind already. I'm going to try and move fast, but I don't want to move so fast that I lose you. So please, if I'm going too quick, just let me know, all right? So where I'm going to start this is on page 9. I'm doing solving linear equations in one unknown. Did y'all have any problems with order of operations? Yes? Yeah? I'll answer one question on that. Which one?
From the homework?
Yeah. Number 12. So this was on page 11, number 12? Okay. This is what I have, 1/3 minus 3/4. That entire quantity is in parentheses, and then it's squared, and then over 2/3. Is that what you have?
Yes.
Yes? Okay. All right, so order of operations, I do parentheses first. So I need to take care of putting these two fractions together. So I'm actually going to do that work on the side. I'm just going to do some scratch work, SW scratch work on the side here. Remember, we don't care about paper and recycling. What do I have to do? Common denominator, which in this case would be 12. So that means I should multiply 3 by 4. 4 on the top and bottom. Watch out there. A little bank shot here, a little Tim Duncan memory there. It was a good run, wasn't it? All right. 3 over 3 there, right? So this becomes 4/12 minus 9/12, which is negative 5/12. Good. All right, 4 minus 9, negative 5 over 12. All right, so this is where we are. We have negative 5 over 12. That's being squared and then over 2/3. So continuing order of operations. I can't do anything with what's in the parentheses, right? But I need the parentheses. They have to be there because I'm squaring the entire number. The negative is going to get squared also. So let's go ahead and take care of the exponents, which are next. So let's do the squaring. And I'll do that over here again. That's negative 5 over 12 times itself, negative 5 over 12. And multiplication straight across. 25 over 144. Negative times negative, positive. So now we have 25, that's 25 over 144 over 2/3. And notice I made that division bar a little longer, just so everyone's clear on what happens now. So division, taking a fraction, dividing, is the same as multiplying by the reciprocal. So I'm just going to turn this into 25 over 144 times what, though? 3/2. Nothing cancels? Yeah? 3 goes into here how many times? 4? 8? Everyone okay with that? Yes? Okay, so everyone understands what we're doing? Yes? 25 times 1 is 25 over 48 times 2, which is 96. Make sense? Okay. All right. Again, I encourage you, if you have the time, to come by my office before class. I don't mind going through problems, okay? I don't mind taking 10, 15 minutes beginning of class to go over homework, but I can't take, 20, 30 minutes every class to do homework problems. All right. I'm working on page 9, and I am going to solve some linear equations. Solving linear equations. I'm going to throw one more thing on here that's not in here. One variable. Later on, we will be solving linear equations in this class, and there will be 2 variables in the problem. That's different, all right? So let's understand what it means when you're asked to solve a linear equation in one variable. And let me just write down the first problem that I have here. 5 parentheses x minus 2 close parentheses equals 4x minus 10. All right. So we're asked to solve, all right, which means that we should get an answer, a numerical answer. All right, we're going to get some numerical answer. You're working with an equation. We notice that we have the equal sign here, which creates the equation. It's linear. Now, what does it mean that it's linear? Okay, when we hear linear, we think line, don't we? But this is actually not a line. We would have to have another variable in there for this to be a line. This is linear because the power on the x is a 1. The exponent on the variable is 1. If we change this variable and raise it to the second power, this is no longer a linear equation. It is called a quadratic equation. And if we change it to a 3 up here, then it's called a cubic equation, and so on and so forth. So the strategy for solving linear equations is different than the strategy for solving quadratics, which is different than the strategy for cubics, and so on. So when we see linear equations, we first must be able to recognize them, and then from there we pull out the tools that we use to solve just those. So does anyone know what the goal is, or how we go about solving linear equations with one variable in them like this? Isolate the variable. That's the underlying thing you want to do. You want to get, at the end of the day, x equals something. And so you want that x by itself on one side of the equation, nothing else next to it, right? The only thing we could possibly say about this x is that there's a 1 in front of it. Other than that, it's by itself, isolated. So to do that, we have to pull everything apart, move everything that's not x to one side, everything that is x to the other side, and then we'd be there, right? But we have to follow all these rules of equations that you can always add something to both sides, you can always subtract, you can always multiply both sides by the same number, you can always divide both sides by the same number, except 0. You can't multiply by 0 or divide by 0. So here's what I'm going to do. I'm going to try and first release this x from the parenthesis, right? To do that, I will distribute the 5 through the parenthesis. So this is multiplication through, pardon?
Sorry. I already, 5x.
5x, that's 5 times x. What's 5 times negative 2? Negative 10. And then you just rewrite everything like this. Okay, so now that you have no parentheses, you're free to move things around. And what I mean by that is move all your x's to one side, all your non-x stuff to the other. And you get to choose. You can put all your x's on the right, or you can put all your x's on the left. It's your choice. We should all get the same answer. So I'm going to choose to go all x's to the left. So how would I do that? How would I get this 4x to not be here? I subtract it, right? I subtract 4x. So I'm going to subtract 4x on this side. I'm going to do this vertically and subtract 4x here. And I think I'm going to also work right now on, well, let's see, space-wise. I don't know where you're going to sit. There's space here. You can pull a chair up on that back table if you want. It's up to you. And that's recording. Okay, so this is going to have the effect of moving all my x's to the left. Yes? But I have a negative 10 over here, which I don't want on this side, right? So to undo that negative 10, I'm going to add 10 to both sides. I'm going to do this all at one time. And as we progress through the class, I won't even show these steps. This is just the first time. All right, so add 10 here, add 10 here. And now we can go ahead and just figure out what happens on each side. So let's see, this 4x, take away 4x is gone. What's negative 10 plus 10? 0. So this side is actually 0. Don't forget that it has to be there. Equals, that doesn't go anywhere. These 10s go away. And you get what? Just x. So 1x right there, right? And at this point, you've isolated x, haven't you? And so we have our solution, x is 0. So what that's saying is that the original equation, right, is only true, this is only true if you replace x with 0. So I'll just do a quick mental check here. If that's 0, this is really just negative 2, isn't it? 5 times negative 2 would give me negative 10. And if I replace that with 0, this is 4 times 0, which is gone, and negative 10. So I'd have negative 10 equals negative 10. That's correct. It's a true statement. That's the only value of x that makes that true. Okay. Questions? All right, I just want to get a feel for where you are. So let's see how quickly you can do this one on your own. Raise your hand when you got your answer. You already did it.
Well, when you said to go through
Oh, you did all of them. Okay, well.
That's it. Yeah, that's it.
Okay, yeah, on these, notice on these assignments, it has like practice problems, then it'll say homework. It says homework order of operations, so you're only supposed to be doing the homework ones. The other ones are the ones I'm going to demonstrate. But you did the linear equation ones because you thought it was before page 12, right?
Yeah, I
Okay.
got it.
All right. Sorry about that.
No,
So you're going to raise your hand when you got it? Okay. Okay. Looks like we got about 5 students done so far. Six, 7, 8, 9, How many of you got 4/3? Okay. So look, time-wise, I think that's probably the most time that you could take on a test on a problem like this. All right? If you're going to get through the whole test, then a problem like this, that's about the amount of time you would need, or you should take. So let me run through the work. There's some things we could have done different depending on how you approach this. First, I combine these two like terms together. 2x take away 5x is negative 3x. Over here, I distributed the 3 through the parentheses and got 6x minus 12. We all good up to that step? We're all okay with that? Okay, here's where people might do something different. How many of you added 3x to both sides? Anyone do that? Everyone did minus 6x? That did it? Okay, so it was kind of your choice. You could have added 3x and then brought your negative 12 over as a positive 12. But I chose to take the 6x away on this side, take 6x away on this side. That leaves you with a negative 12 here. And then over here, negative 9x. At this point, to get a 1 in front of here, we have to undo the multiplication. So we divide both sides by negative 9. Negative 9 divided by negative 9 is positive 1. So that's why I did this. And then negative 12 divided by negative 9 is really a positive number, right? Negative divided by negative. And then I reduce the fraction. This all clear? So if I'm working up here and you're just sitting there going like, man, what the heck is going on in here? If this is like kind of already past where you feel comfortable, then you should talk with me. Don't just continue through sitting through this class getting overwhelmed, all right? I know it's hard to like raise your hand and you know, you feel embarrassed maybe sometimes, but you have to identify If you've got some holes that need to be filled in, we need to identify that as soon as possible. All right. There's a little plaque that my dad has above his dresser. I remember reading it as I was a kid, and it says, "Your only obligation in life is to be true to yourself." And I've always remembered that, because there's no sense in you lying to yourself about where you are here, right? This is about your education, and if you're struggling at this point, you got to be true to yourself, and you have to address it. You can't just hope that you just get, float along in here, right? Okay, let's try something a little more challenging, I guess. 10x plus 4 minus x in parentheses equals 7x plus 2, and then the quantity 3x plus 5. All right. So again, we're solving a linear equation. We know that because there's an equal sign. We see one variable, and the power that that variable is raised to is 1. So it's a linear equation, one variable. We're hoping to get all the x's on one side, but I have to free them from any parentheses if they're trapped, right? So how about this first set of parentheses? It's kind of weird, because there's not really a number. If there was like a 3 here, you would just distribute, right? So this is kind of confusing. What is actually the number sitting in front? It's a 1. So a 1 would distribute through here, which would mean nothing. It would just be the same thing. So those parentheses aren't even necessary, are they? They are put here just to make sure you know that, right? Just to make sure you're aware of that. Now on the other side, I can pass the 2 through. So 2 times 3x is 6x, and 2 times 5 is 10. So now I'm going to go through the process of what's called collecting like terms. So on each side of the equation, I try and put things together. So what can I put together here? 10x and negative x, which would give you 9x's. Plus 4, still there. Didn't do anything with that. The other side, 13x's plus 10. And now you're at a point where you can start moving your x's to this, you get to choose the side. I'm just going to continue to go to the left with the x's. So I need to do what? If I want to move the x's to the left, what do I need to do next step? Subtract your 13x from both sides. And while I'm at it, I may as well do what? Subtract 10 on both sides? Subtract 4 on both sides, right? Because my x's are going to be over here. I don't want this 4 here. So I've got to undo the positive 4 I subtract. Why don't I divide by 4? Because it's addition. So you're undoing addition. To undo addition, you subtract. Okay. So what do I get on my left side? These are gone. 9 take away 13 is negative 4, but I had x there, so negative 4x. Right side of the equation? 6, right? These went away, but this was 6. Now what? Divide both sides by negative 4. And that's because you were trying to undo multiplication, right? There's multiplication there. You're trying to undo it. You undo it with division. The left side of the equation will turn into x. And the right side, 3 over 2 negative, right? So could I write this? Negative 3 over 2. Would that be correct? Yes? I'm asking, are these different? These are all equal. Okay, so please remember this. If you have a negative in a fraction, okay? If the negative is on the bottom, you are free to move it to the top. Like I did here, right? Like this would have been negative 2. So this would have been what most people got here. But you are allowed to take that negative and put it to the top. Or you can put the negative out front and leave these two as positive numbers. Think about it. This is a negative number, isn't it? Negative divided by positive should be negative. This is a negative number. Positive divided by negative. This is a positive number, but you're making it negative. And they all have the same value. So these are all equivalent. All right, moving on. What if you have something like this? X minus 2 over 3 equals x minus 1. Now, actually, they had it written like this, in parentheses there. But you tell me, do I really need those parentheses? No, because the parentheses have a 1 in front of it, right? This is a 1 here, and the 1 would distribute through, and it wouldn't change anything. So there's no harm in us not even writing those. But now we want to try and get the x. How is this problem different than what we've seen before? Yeah, we've got, this whole thing is being divided by 3, isn't it? Right? The whole thing? So how can I kind of clean up the fraction here? Multiply both sides by 3. So what we do in this case when we have a linear equation and we have fractions involved, we try and clear the fractions. So we try and multiply through by something that's going to remove any denominators. So the only denominator I have here is 3, right? So I'm going to use that number, 3, as my common denominator, and I'm going to multiply both sides by 3. So let's see what happens. If I come in here and I multiply this side by 3, not 3 over 3, but 3 itself, I'm going to have to do this multiplication, right? This is the same as 3 over 1, just so we're clear. Then on this side, I have to multiply by 3 also, right? When I multiply this side by 3, though, I have 2 terms here, right, separated by subtraction. So the 3 that I multiply here must go to both of these. Now tell me what I can do on the left side. I can cancel these 3's out. All right? That's the whole point of us coming in with a 3, is that these are common factors now. I can cancel them out, and I've removed the fraction completely. So I just have the x minus 2 that's left. Any questions on that? Right side? 3x minus 3. So you distribute through 3x minus 3. And now this looks more like what we had before, right? Would anyone have done this any different? So I can help anyone that might have gone on a different path? No? Okay, so here I'm going to do this mentally. I'm going to move this 3x to this side, which means I'm going to subtract it. When I subtract 3x from x, I get negative 2x on the left. I'm going to move this negative 2 to this side, which means I'm going to add it to both sides. Negative 3 plus 2 is going to give me negative 1. And when I divide through and clean up, I get 1/2. So I'm not showing some work there. Right? If you needed to, I would encourage you to show the work. All right. This would be a little harder to check, wouldn't it? This would be a little harder to check. We would have to take 1/2, plug it into the original problem, see if it worked. Y'all understand what I'm saying? If we had to check that? In fact, think about this. Let me see. Without doing anything, can anybody tell me what the answer to that is?
5.
Close?
No, sorry. 4.
4. Does everyone agree if you just look at that, the answer is 4? 2 times 4 is 8, plus 1 is 9. Yes. Now, what if I do this? A little bit harder, right? What if I do this? A little bit harder, right? It keeps getting harder. What if I do that? Now it's getting even more difficult for you to just look and see, right? This is why we have algebra. is because when we're faced with something that's not easy to look at and get an answer, we have to have a process to get to the answer. So when you look at this original problem, I can tell you right now that if you looked at this in the very beginning, when I put that on the board and you looked at it and went, yeah, it's 1/2, then you probably shouldn't be in this class, all right? Because no one's really going to look at that and know the answer is 1/2. So how do we get to the answer? All the process that we just went through, all right? Okay, let's try something a little different. Two fifths x minus 5/7 x equals x minus 1. Same approach as last time, all right? You don't like fractions. I like them. You don't, that's okay. So if you don't want to work with fractions, when you have equations, you have the ability to get rid of fractions. So you have to find this common denominator and multiply both sides by that. So what is the common denominator in this problem? 35. How are you getting that? You're looking at the two denominators, right? 5 and 7. You're trying to come up with a multiple of both. So you could list them all out, or you could just multiply them together and use that number, 35. So I'm going to multiply both sides of this equation by 35. So it's going to look like this. This side of the equation by 35, and this side of the equation by 35. This is called clearing the fractions. Now when you do this first multiplication, you distribute through, right? We have to do this here and here. Think about what this first multiplication is. It's the number 35 times 2/5 times x, right? So I could write this as 35 over 1 times 2 over 5 times x. That's what that is, technically speaking. Now I know some of you are just going to say that's 14x and be happy, and that's okay. But this is what we're doing. Y'all agree? Now when I do the next one here to here, I'm going to have a minus sign. It'll be 35 over 1 times 5 over 7 times x, right? And then equals, the other side I'll take care of in a minute. So I did this so that you could see where the reducing of the fraction is going to occur. This 5, right? 5 goes into 5 one time, 5 goes into 35 7 times. So what you're left with here is 7 times 2, right? And 1 times 1. So what is that? 14 over 1? So that's just 14x. And then over here, 7 goes into 7 one time and goes into here 5 times. So what do I have there? What's my second term right there? 25 over 1 times x, so minus 25x. And then equals, we never did the right side, did we? But that was here and here. This was 35x minus 35. So 35x minus 35. And now we go about trying to get x by itself. And we've cleared the fractions, so it's a little nicer to look at. What should I do? What would you like me to do here? You want to take this over now? I can do that. That's fine with me. So I'll have 14x minus 25x. When I take this to the other side, what I mean is subtracting it on both sides, right? So I'm going to subtract it on the left side. And on the right side, what's over here? If I move this over and subtracted it, what's still here? Negative 35. Now notice that I didn't do this time. Do you notice I didn't do that? Okay, when we do this, it's called vertical addition or subtraction. And this is called horizontal. I'm just trying to show you both methods. And we want to really be to a point where you're comfortable moving things left and right. Hopefully that's where everyone is in here. It's hard for me to stand up here second day of class and know where everyone is. It's hard, very difficult. So, can we put all those three together? Yeah, just put the numbers together, right? What's 14, take away 25, take away 35. So, negative 46x equals negative 35. Now what? Divide by negative 46 on both sides. And I'll have a negative divided by a negative, won't I? And that'll just turn into a positive. It's not wrong to leave them both negative, but it's one of those things where I'm grading it and I see this. If that's your answer at the end and you box that, I just kind of go, just a little sigh, and that's it. And I just keep going, all right? Because it's not wrong, it's just you don't recognize that two negatives make a positive. Does this reduce? They don't. Here we go. Yeah, so I don't think anybody looked at this and went, oh yeah, of course, if you plug in, 35/46, that'll be a true statement. How are y'all doing? You all right? I mean, I know it's 2 hours of math. I mean, there's not many things you could do that would be more exciting than this. I understand that. Okay. I'm going to just throw something up here. What are you looking at here? It's an expression. Good. It is not an equation. So you are not going to do what you were just doing, which was solving an equation, right? That means you're going to simplify the expression. And that just means try and, make it look as pretty as possible. And the only thing I can see that we could possibly do here is put these x terms together. These both have x, right? Let's try and combine them. So I'll just do one more line here. I'm going to say that this is equal to, now I know you're going to say, wait, you just made an equation. No, I'm just saying that this expression is equivalent to this new expression, 1/3 x plus 1/4 x minus 1, right? Do you agree with that? Writing x over 3 is the same as writing 1/3 times x. Do you all agree with that? And I only did that because we can put these two together if we can just somehow combine these two numbers together. So you do not have the ability in this problem to come through and multiply by the greatest or least common denominator because it's not an equation. You can't work with both sides that way. There were no both sides to start. So you really just have to do some scratch work over here. You just have to put 1/3 plus 1/4. Get your common denominator, right? Multiply by what you need to multiply by. You should get some like 4/12 plus 3/12, right? If you do this, that'll give you 7/12. So this becomes 7/12 x, and then you still had what over here? Minus 1. And that's it. You box it. That is the simplified expression. X over 3 plus 1/4 x minus 1 is equivalent to 7/12 x minus 1. Done. Now compare that problem to this problem. I'm going to take this same thing right here. I'm going to change that to an equals 1. Totally different ball game now, right? We have a linear equation. I have fractions. I don't like fractions. I'm going to clear the fractions. So I'm going to multiply both sides of the equation here by 12. So I'm going to multiply 12 on this side. Since there's two terms, I need parentheses. Over here, 12 times 1 is just going to be 12, so that's pretty clean. And let's see if we can do this one a little bit faster. What would we get if we did this to this one? The 12 and the 3 would reduce, right? And you would get what there? 4? You get 4 x's. And then when you go here to here, you're going to have a plus between them. And what would happen when you take 12 and multiply by 1/4? So that would reduce again, right? And you would get, careful, you're doing 12 times 1/4, which is same as 12 over 1 times 1 over 4. And then this would become 1 and then 3. So it would become 3 over 1, not 1 over 3. Right? So you just get 3? 3 x's. Equals 12 times 1. So 12, right? Now combine your terms on the left side, 4x and 3x is 7x. So this is 7x is 12. And finally, divide both sides by 7. 12 over 7. The solution is 12/7.
If we put that as a mixed number, we still be ready to leave like that.
If you put it as a mixed number, I would not count it wrong. Okay, you should be able to handle that homework, hopefully. Everything up through 12 now. Page 12. And now I'm going to move to page 13, which is operations with polynomials. So I'll try and add a couple of random bits of useless information throughout the semester just to keep us from going crazy in here. You know how I've been saying, like, don't worry about paper and, right? You all don't care about recycling, right? That's what I'm gathering from you. All right, so I had this conversation with my wife many years ago when she wanted to have a special can in the kitchen for recycling. And so, like, for the first few years, you know, I would take the can of recycled stuff, take it to the side of the house and throw it away with all the other trash. I wouldn't recycle it, and she would get all pissed off at me. Kind of the same look you just gave me right there. I know, it's sad. So anyways, we got, she got upset. She's like, why are you doing that? And I'm like, well, okay. The savings, okay, a lot of the savings that you think you get with recycling are actually countered by the amount of pollution and other things, byproducts of the actual process of recycling. Just think about the recycling trucks that drive around and how much energy goes into separating the trash from the recycle, because people don't follow the rules. They throw their trash and the recycle together. Anyways, so we got in this big heated debate about it, and I'm recycling now just to appease her. But I'm not a big fan of it. And my ultimate argument to her is this one. Any of you taken an astronomy class yet? Okay, if you've taken an astronomy class, you probably know that our sun is a main sequence star, and that it has a lifespan. This is the sun. And here's us. I'm just going to put E for Earth, okay? And at some point, I'm not going to quiz any of my astronomy people, but, well, unless you want to tell me what's going to happen to our sun. It's going to get real big. It's going to expand first before it dies. And then it's probably just going to collapse and die out. But in that expansion process, it's going to pretty much vaporize everything that's on Earth. It's going to be the ultimate recycling of everything. So I'm not too concerned about recycling. all right? It's all, at least, I mean, everything here is going to get recycled one way or another, all right? What's that? Well, I mean, it's
Science. We'll be gone, so.
will we be gone? You think so? These are debatable topics, which is why I stick with the math, because there's no ambiguity here. There's no gray areas, at least not here. All right, so operations with polynomials. We should probably talk about what a polynomial is. Poly meaning many. A nomial is a term. A term is anything that looks like this. 4x, 3x squared, negative 7x to the third y. MNP, I'll throw a number so you don't freak out, 10 in front of it. These are all nomials, monomials, single terms. Things, we have numbers and letters separated with multiplications. These are multiplications, right? Even the exponent is in multiplications, repeated multiplication. So a polynomial is many of these together. And that's what we have here. And we need to be able to manipulate or do certain operations with polynomials. And in this case, we have a polynomial here, and we have a polynomial here, and they're being subtracted. So we just need to make sure we are clear on how to subtract these and when we can or cannot combine monomials together. So what do you need in order to combine two things together? Like, I can't combine these two together, can I? Like, could I make that, like, if I asked you to add these two? Could you add those two together? No. It would not be like 7x to the third or something like that. It wouldn't be that, right? What do you need in order to put these together through addition or subtraction? What has to be the same? Same variables with the same exponents. They have to match. So I can only put x's with x's, x squareds with x squareds, right? X cubes with x cubes. If I have a 10mnp, I can only put it together with another something mnp. Got it? All right, so I'm using a variable here in this problem, or they're using a variable a instead of x, just because, you know, let's get all the letters involved, I guess. What about this parenthesis? What can I do here? Do what? Get rid of it? How do I get rid of this parenthesis? Distribute the 1. So it's really just, when you say get rid of it, you meant just get rid of it. Because there's a 1 that goes through, nothing changes. On this one, however, we've got a little bit of a different issue, right? And this is where people get caught up, right? This is a negative sign, so you're going to subtract that entire polynomial, which means you're going to subtract this guy, and that's a girl. These are two guys, this is a girl. So do that, right? Change the signs, basically. You have to do a lot of math before you can start to identify genders. Okay, so if you can't tell if this is a girl and that's guys, don't worry about it, right? Look, I'm trying to bring some humor in here. If it's bad humor, just accept it, okay? Anything, right? Okay, changing the signs. This expression is equal to this expression, and now I combine like terms together, if possible. So do you see anything I can combine? Let's start with the A's. I've got a 3A there. I've got minus 1A, right? So I can put those two together, which would give me how many A's? 2 A's. Now, I like to just kind of mark these out. Let's go after the A squareds. A squared, 2 of them, take away 2 of them, they're gone. So 0. So I don't need to write that. These are completely dead. And 3a cubed plus 3a cubed, 6a cubed. And at this point, you're done, okay? You have combined these together, box it up, move on. That's how you subtract. If this was addition instead, then these signs would not have changed, right? And then it would have just been plus A, plus this, minus this, and it would have been a different answer, right? Okay. Now let's do a little multiplication of polynomials. Multiplication, let's do this one. Bless you. Was that a sneeze?
Yes.
Okay. I had a girlfriend back in high school who would sneeze and she would like load up, you know, and I mean you could see her loading up, and then she would just go, it was just like a little, and that was it. And I always told her she's like gonna blow her brains out her ears or something, you know. Let it go. What does that mean, squared? Squaring that thing. Just multiply times itself, right? Now, what's the most common mistake made here? Yeah, a lot of people will just square each of these. Say, I'm just going to square this, which is what, 25x squared. So you're squaring 5 squaring x. And then they say, I'm going to square this. What would you do if you did that, if you squared this? Would you do plus 4 or minus 4? Yeah, so this is a mistake that people make. This is incorrect, all right? What you have to do is write it out and then use this thing. I already heard it. What was it? Foil. Foil. Your second favorite 4-letter F word. Foil. What does FOIL stand for? First, outer, inner, last. Okay. Not a fan of this personally. I know it's cute. I know, it's an easy way to remember, but I'm not a big fan of it, and I'll show you on the next problem why I'm not a fan of it. For this one, I'll go ahead and use it. So what we're going to do is we're going to take this one right here, first one here, we're going to multiply those together, right? So we're going to multiply that times that, which is 25, 5 times 5, right? And then x times x, we write that as x squared. Then I'm supposed to do the outer ones. What we mean by that is the outer two guys right here. This one, this one. So I'm going to multiply really this times this, right? What's 5x times negative 2? Negative 10x. And then after I'm done with that, I'm going to do the inner ones, which is the two that are inside. Multiply those together. So I'm going to do this one times this one, right? Which gives me negative 10x. Again, that's the same thing I had a second ago. And then the last ones means the last one here and the last one here together. So here to here, negative 2 times negative 2 plus 4. And then I try and combine any like terms together. So combine these. These x's can go together. So I have 25x squared. These two together become what? Negative 20x, and then plus 4. And that's it, right? It's an expression, so I'm done. But I'm going to try and, I want you to remember FOIL, because like I said, it sticks for a lot of people. But I want you to recognize a pattern here that we did. If I would have given you these instructions instead, we would have turned out with the same thing. Where did that red one just go? Oh, okay. All right, so what if I told you if you're ever going to multiply polynomials together, you always start with the first term here and just pass it through everything over here. Then after you've done that, move to the next one and pass that one through. You would have done the same exact thing. It would have been FOIL. That's exactly what I'm about to do on the next problem, and you'll see that I think it's more powerful because you can do things that have more than 2 and 2. You can do like 2 with 3, you can do 3 with 3, you can do 8 with 7. It doesn't matter. You just follow a process. So let's try.